this is my parent function right here, all right, of a reciprocal. Where are the parentheses technically in this one? In the bottom, in the denominator. So the right 2 would go there. So I would go x minus 2 would be on bottom. The up 3 would be here. And then the vertical reflection would get shown where? Up top, right there. So that's what I would be doing. So I could give you transformations and you write the equations, or I could give you the equation and ask you to tell me the transformations. Okay?
So on the text you'll give us the, like, one of each or whatever?
I could give you that and ask you to do that, or I could give you this and ask you to give me that.
And then how many problems will be?
A couple of those. Yep. Okay. All right. Now, the next thing I want to look at is I want to look at this problem right here. So I'm going to give you a little chance to copy that down. So I got f of x equals x minus 4 and over 3x minus 2. Okay. And what's it asking me to find? Somebody said the inverse. That's correct. Okay. And so how do I find inverse? What's my first step? Switch x and y. So I'm going to put x over here, and it's going to look a little bit funny to start. Sorry, I wrote that wrong. Let me fix that. That's just a y on top. And then, so I'm going to have two y's. Because wherever there was an x, I'm putting a y, and wherever there was a y, I'm putting an x. So I'm just switching the x and y's. So this is what it looks like. All right? Nothing else. That should get you a point on the test. All right? By switching x, y. Now, what's our next step? All right? We're going to get rid of the fraction, but we're trying to get the y by itself is what it is next. Okay? So switch the x and y. Try to get the y by itself. And so I agree. We've been doing a lot of this multiplying by that right there. So those cancel. I'm going to go in and distribute over here on the left-hand side. So I have 3xy minus 2x equals y minus 4. Now what's weird about this one getting the y by itself? You could divide by y, but you'd have to divide everything by y. But you got two of them, correct? So I'm going to put them on the same side. So I'm going to go minus y here and minus y there. I'm going to take everything that's not a y and I'm going to put it on the other side. So that's going to cancel, that's going to cancel. So I have 3xy minus y equals 2x minus 4. I now have the y's on the same side. I'm trying to get the y by itself. What could we do here? This is kind of the tricky part, or this is the different part of this right now. I can, well, if I divide by 3x, I can divide everything by 3x. There's a y right here on both of these. So I'm going to factor that y out. So I'm going to take the y out and put it out front. So that would give me 3x. What's y divided by y? 1. So that's a negative 1 equals 2x minus 4. Okay? Now I have the y by itself. Now, how do I, many of you are making mention of this, but we've got to now do it at this step. How do we get rid of 3x minus 1? Divide. Now we divide by that. That's correct. Okay? Now we divide. So divide by 3x minus 1. Divide by 3x minus 1. All right? So my inverse in this case is 2x minus 4 over 3x minus 1. Okay? Still the same steps that we did last unit, but it's a little bit tricky. It's got a little bit of a different move in there as we're going. Okay? All right with that? So you have one inverse problem on the test. So you'll need to be able to do that. And it may not even be that hard. It may be a little bit smaller one. But you do need to be able to switch the x and y and then go solve for y. Okay? If I were to give you this right here. If I give you f of x equal, and I give you g of x, excuse me. And I tell you that h of x, h of x is f of x over g of x. Okay? Well, what is f of x? What type of function is it? It's just linear, so is g, it's just linear as well. But if I were to build h of x like this, all right, x plus 1 over x minus 4, because that's what f of x is, that's what g of x is. Now h of x is this, and then they could ask me, okay, what's the horizontal asymptote? What's the vertical asymptote? What's the x-intercept? What's the y-intercept? So now I built that rational function. See how I did that? That's kind of like a composition. I'm building it from two functions, but it's telling me what to do with it. So just follow along. It looks weird, but just kind of follow what it says. Okay? Everybody all right with that one? All right. Now let's talk about composition. So if I were to do this right here, if I were to give you that same one right there, if I were to give you x plus 1 over x minus 4, I'm going to call that f of x. And I have g of x is 2x plus 3. So f of x is x plus 1 over x minus 4. G of x is 2x plus 3. And the question I ask you is to go find f of g of x. We can write it that way, or if you want to write it the other way like this, that's fine. But what am I going to do? How do I create this composition? Put g, bless you, put g in the f. And I'm going to put g in the both spots where I see the x. Okay? So I've got 2x plus 3 plus 1 over 2x plus 3 minus 4. Is this really any different than we did on the last unit? Same thing, it's just we're applying it in this function right here. We're seeing one of those. Now, I'm probably not going to leave that. I'm going to go in and combine like terms. So 2x plus 4 over 2x minus 1. Can I get rid of the 2 x's? It's division. So in order to cancel top and bottom in division, I have to have multiplication. This is addition and subtraction, so that's the best that I could do there. All right? I can't cancel that top and bottom. If it was written like this, something like that, 2x and x plus 1 and 2x and x minus 2, if it was written like that, now that's written in multiplication, now the 2 x's would cancel. Okay? About right there.
Yes.
One last question on this. If I ask that question, what are you going to do here?
Like X back to that.
This is my x value. So I put x that, put that for x right there, which is basically the same problem that I just did, correct? I just asked it a different way. You see it? All right. So I asked it with compositions here. I just asked it with simple evaluation here. I mean, I could even do something as easy as that right there. You're just going to take the 4 and go plug it in. You got it. Okay? That's evaluate. Everybody good there?
Yes, sir.
All right. These are all things that we talked about last unit, but I'm just kind of applying them to the rational and reciprocal. All right. One last thing. We've talked a little bit about solving. We've talked a little bit about solving. We did a little bit of it by hand, but I want to do a little bit more complex one with you today. We didn't get to this yesterday. I planned to, but ran out of time. Okay? So I have this equation here. Before I get started too far in this problem right here, is it undefined anywhere?
Yeah,
Where?
x is -1.
Okay, x cannot be -1. If x is -1, that would create a 0 on the bottom.
Or if it's 0.
Or 0. I can't use 0 either. Okay? So most likely, if I were to draw a picture of this, it's probably got a vertical asymptote at 0 and at -1. That's kind of the same things you just did on the quiz a while ago. All right? So those are kind of like finding my vertical asymptotes. Now, here's what I'm going to do. How have I been getting rid of the denominators? We've been multiplying by them, right? But now we have two different ones. We're going to multiply by both. So we're going to multiply by 2x, and we're going to multiply by x plus 1. So I have two different denominators. I'm going to multiply by both of them. Okay? What happens in this first one? The 2x's cancel, but I'm left with 3 and x plus 1. So that's what's left here. The 2x's cancel. I'm left with 3 and x plus 1. Minus, in this next one, the x plus 1s would cancel, and it leaves me 2x and 2x. So 2x times 2x. In this last one over here, nothing cancels, so I'm just going to multiply it all together. So negative 2, 2x, and x plus 1.
Didn't we do this last year?
We did. We did this last year, and it's part of our reciprocal and a rational function. Just kind of reviewing it here. All right? Now, I don't like all the parentheses, so I'm going to distribute and make it a little simpler there. So I'm going to go 3x plus 3. What's 2x times 2x? Negative 4x squared. Yep, good. What I would do probably on that one is I'd probably multiply that together first and get negative 4x. Then negative 2 and the 2x, get negative 4x. And then let's distribute that. So negative 4x squared and negative 4x. Okay? All right. What type of equation do you see in the blue there? It is quadratic. That's right. How do we solve quadratics?
Factor.
Factor them, but before we factor, get it equal to 0. So move it all to one side and then try to factor. I agree with that. That's good. Okay? So I'm probably going to move it to the left. So I'm going to add 4x squared, and I'm going to add 4x squared. I'm going to add 4x, and I'm going to add 4x. So I moved it all to the left. So I have 7x. I have 3. What's the nice thing here? They cancel. So what happened to my quadratic? It's gone. I don't have to do the quadratic anymore. All right? And all that over there is 0. So now I'm just dealing with a linear one. Okay? So this worked out well for me. It may not have. It may still be a quadratic and I have to factor. But for right now, I can move the 3 back over and divide by 7, and x equals negative 3/7. Is that answer okay? What's the only answers I couldn't have?
Negative 1 and 0.
Negative 1 and 0. So I got an answer that was okay. It's not one of these, so I'm good. Okay? All right. For this evening, all right, or until Monday, we did page 206 earlier in the week, but we didn't do the bottom row. So that's where a couple inverse problems, a couple composition, some things like that. So what is that? 5, 7, 11, 12, and 13. All right. So those are some good review problems, some good little problems to be able to handle for there. Okay? So that's what we have. Don't go all weekend long without looking at this, and the next time you look at this is when we take the test on Monday. That wouldn't be a good idea. Okay? I'm not saying study all weekend long either. All right? But balance your time. Go from there.